Today we're going to talk about exponential regression. So exponential regression, just in general, a regression line actually helps you make predictions. So basically you get a table of values and you have some data points and you look to see what kind of line best fits those data points. And we're just going to particularly look at the exponential today. Once you figure out your regression line, which is the line that fits the data the best, you can use that to help make predictions. And so that's what we're going to look at. And we're going to be using Desmos to do this. Okay, you guys actually did this in Math 1 for linear regressions, and Math 2 you did quadratic regressions. Okay, so for number 1, the table below represents the number of teams that play in the NCAA basketball tournament for each round. Graph your data and compute a regression equation. Okay, so the first thing is we have our table here, and within our table we're going to actually make a table into Desmos, and this is going to be our x values and this is going to be our y values. So if we go into Desmos, to the left hand side up on the top there's a plus sign. If you click that plus sign, it gives you a drop down menu and you click table. So in that table, I'm going to enter what I had for the number of rounds. That's 0, 1, 2, 3, 4, 5, and 6. And be careful that you don't hit enter, because if I hit enter after that 6, it's going to put a new number there, and it only goes up to 6. So I just hit the backspace. And then there was 64 teams, 32, 16, 8, 4, 2, and 1. There's a little magnifying glass on the bottom in that blue bar on the left-hand side. It's a magnifying glass with a plus sign. It says zoom fit. If you click that, it's going to adjust the window so you can see all the data points. Okay, so this is actually showing exponential decay. So what we need to do is we need to come up with a prediction line that's going to fit these data points. And we're going to specifically do exponential regression. So when we do exponential regression, and you need to write this down somewhere so you can refer to it. When we're doing it in Desmos, we set up the equation in the form of y sub 1, put your little squiggly, a, b, and b is raised to the x sub 1. And I'm going to show you why they're sub 1s. Okay, so we already talked about is y equals a times b to the x power. We've been using that format since the beginning because it was exponential. And we're looking at these all being exponential today. Okay, so back to my graph. Below the table, there's two ways you can do that. You can hit the plus and add an expression, or below the table, if you just click below that blue line, it's going to give you a new rectangle there. Okay, so this is where we're going to type that equation the format of the equation I just wrote. So you're going to type in y. Now, if your table, the keyboard probably won't be showing. So if you click down here in the bottom left corner, it says show keyboard. And then if you hit the big ABCs, the first button to the right of 1, 2, 3 is A sub B. That's your subscript button. So you click that button, you type in a 1, and then you can either click so that it gets off of the subscript, or you can arrow to the right. And we're going to put that little squiggly. So that little squiggly on the keyboard from the 1, 2, 3 is down here on the bottom. That's your little squiggly button. That's that symbol. The other way you can get that symbol is if you do shift and then the button to the left of the 1 on your keyboard. And then we're going to type in A times B, but that B has to be raised to the X sub 1. So to the right of the 1, 2, 3 is your subscript button. Whoops, didn't mean to do that. So let me get out of that. We have to do the exponent first. So we have an exponent. So one of two ways you can do the exponent. If you click that 1, 2, 3 to go back to your home screen, you can do this A raised to the B button, or you can just do your Shift 6 to make it become an exponent. Then we're going to type in our x, and then to get the subscript of 1, you click that ABC button. A subscript of B is the first button to the right of 1, 2, 3. And you type in your 1. So when I do that, it automatically, you can read my keyboard, it automatically draws the line of best fit. That's your regression line. That line would be used to make predictions. This, if you notice, it actually goes through all of the data points that we put there. This is a perfect fit. That r squared value is your residual squared. And if that number equals 1, that is a perfect fit. So exponential was a good choice for this one. Okay, also, under the parameters, if you notice, it tells you A is 64, B is 0.5. That's what you're going to substitute into your equation to write your equation. When you're asked to find an equation, you write the equation you found. So the equation that we're writing for number 1 was y equals A was 64, B was 0.5, and it's raised to the x. And that's our prediction equation there. Okay, for example number 2, the population of bacteria triples every hour. Initially, there are 100 bacteria. Write an exponential equation to express this population. So we're going to start there first. Okay, so what we need to do is this one does not have a table of values, so we are going to make a table of values. And we were talking about the number of bacteria tripling every hour. So we're going to say the time, and that's going to be in hours. And we're calculating the number of bacteria. Initially, there are 100 bacteria. That means at time 0, at the start, the number of bacteria is 100. After that, it says every hour, the bacteria triples. So in 1 hour, the number of bacteria, that 100 triples to 300. One more hour later, so in 2 hours, that 300 is going to triple again to 900. In 1 more hour, so after 3 hours, that 900 triples to 2700. You'll probably want 3 or 4 values in your table when you go to do this. It actually can be done with just 2, but 3 or 4 is usually a pretty decent amount. Okay, so we're going to come up with our exponential equation based off of this table. So I'm going to go back into my Desmos graphing. If you can actually hit the X's to clear it out, or you can hit this little gear up here and then click delete all, and it takes everything away. All right, so I'm going to hit my plus, and I want to make a table. And so in our table, we said we had 0, 1, 2, and 3. Oops, I did not want that 4. I keep doing that. And then for 0, we had 100, 300, 900, and 2700. Now I'm not seeing anything, so I click this little magnifying glass for zoom, and it graphs our points. To get the line that's going to help us make predictions, which in this example we will actually make a prediction, you either click the plus and add an equation, add an expression, or you can just click below it. Okay, so we're going to type in that same equation, y sub 1. So remember, you're going to the keyboard, the ABC, and then it's A subscript B. Type in your 1, arrow to the right, do your little squiggly, and then it's A times B, and that is raised to, so I'm going to hit my 1, 2, 3 and do A raised to the B, x sub 1 power. So I have my x, I have to hit the ABC again, my A subscript B, and put my 1. And it's going to graph the equation for me. It graphs it and it creates it for me. Again, we have a perfect fit because that r squared value is a 1. We will not always have a perfect fit. But it does tell us down here that we're going to replace A with 100 and B with 3. So that's the first thing it asks us to do, is to write the exponential equation. So our exponential equation is y equals, we're replacing A with 100, B with 3, and it's raised to the x power. It has to have that x power for it to be exponential. Okay, the next question says, the first thing was to write the equation. We did that. How many bacteria will there be in 6 hours later? So the bacteria, remember the bacteria was our y values. The hours was our x values when we made our table. So 6 hours is an x value. So basically you're looking at, okay, when x is 6, I want to know the number of bacteria, which is y. So we don't know y. So to do that, we go into our Desmos, and we're going to click another box below the equation. And we said we want to know when x equals 6. So that's exactly what you're going to type in that box, x equals 6. Now x equals 6, my x only goes up to 4 right here. So I'm going to do the minus to zoom out. And I'm actually going to do it a couple times, and you can actually also drag it. But here's our x equals 6. Okay, so x equals 6 is a vertical line. We're looking at where do these two intersect. So I'm just going to I have to zoom out quite a bit here. All right, so when x equals 6, right there it is. X equals 6. I was just going along the line until I found x is 6. We have 72,900. So that's our answer. So in 6 hours, there will be 72,900 bacteria. So that's answer number 2. The third question says, when will there be 100 bacteria or 100,000 bacteria? So when is the time? When is how many hours? So we do not know x this time. We want to figure out x when the number of bacteria, which is our y value, is 100,000. Okay, so we're going to go to the calculator again, and we're going to type y equals 100,000, and we're going to figure out the x. So if I go here, I'm going to click below to get a new rectangle. We're going to type y equals 100,000. Now y equals 100,000 is going to be, if it's x equals, it's a vertical line. If it's y equals, it's a horizontal line. And it's actually color coding it for us. The red one is our vertical, the blue one's our horizontal. So we're going to come down here. I'm just going to click up in here, and I'm going to kind of go along there until I see the y value being 100,000. And so the x value is 6.288, the y value is 100,000. So our answer is 6.288 hours. So in 6.288 hours, there will be 100,000. Oops, forgot the will be. There will be 100,000 bacteria. That's our third answer. Now I just want to kind of go back real quick and show you guys something. When we were talking about the number of teams were decreasing, which is a decay. Notice the starting number of teams is 64, and that is our A value. And if you also notice the number of teams each time you're taking half the number of teams, that's why the B value is a half. So sometimes it's consistent all the way through the table, that you can actually use your table to help figure out writing the equation without doing the regression line. But that doesn't always work, and we're going to look at our third example where it doesn't. When we look at number two, our starting number of bacteria was 100, so that's why our A is 100, and it tripled. So each time the Y value you're multiplying by 3, it's consistent through all the values. That's why this base here is a 3. So that B value is a 3 right there. So that's just something to kind of look at. Now when we get to this last example on number 3, when you look at the Y values, there's nothing consistent about these. So the only way to come up with a regression model here is to actually put it into the calculator. All right, so we have a cup of soup left on a countertop to cool. The table shows the temperature in degrees Fahrenheit of the soup recorded over a 10-minute period. So we're going to write an exponential regression model for the data. So we're going to go into our Desmos. I'm going to click the gear and delete all. Click the plus and a table. And then we're going to put the values for that table. So the x's are 0, 2, 4, 6, 8, and 10. And then the temperatures were 180.2, 165.8, 146.3, 135.4, 127.7, and 110.5. And I really do recommend that when you're putting values into a table like this, that you double check to make sure you put them in correctly, because one little mistake by putting like an 8.7 is going to throw off your answer. And there's only one answer to the problem. Okay, so I'm going to hit my little magnifying glass over here to see my points. Now that looks more like a linear expression to me, but it did say exponential, because that kind of looks like it's a line with a negative slope. So to get the exponential, our last example here, we're going to click below and we're going to do our Y. I'm going to hit my keyboard and we're going to hit our ABC, A sub B to get our 1, arrow to the right, put our squiggly, AB is raised to, so I'm going to hit the 1, 2, 3 to get the A raised to the B. X, and then I have to have our sub 1. So I'm going to click the ABC to get A sub B. Type in my 1. Okay, so there's our graph. So notice this one doesn't go directly through every point. It's the best fit. So it's kind of it actually determines where the best fit of that line would be to help make predictions. Notice the R squared is 0.99899. So it's not 1. It's not a perfect fit because it's not going through every data point. But the closest it is to 1 is the better fit. And so this is a pretty decent fit here. We have our value for A, 180.325, and our value for B. You can round to the nearest hundredths, or you can write all the decimal values, because the most number of decimal values that you'll ever see is 6. Okay, so let's go ahead and write our equation. So to answer Part A, the exponential regression model is Y equals, our A value was 180.325. Our B value is 0.95. I'll just go 2 decimal places on that one, and it's raised to the X power. Determine the temperature of the soup after 30 minutes. 30 minutes, the minutes was our X, the temperature was our Y. So that 30 minutes is an X value. So basically that's saying, okay, well, X is 30. I want you to find the temperature. So it says determine the temperature. That's your Y that we have to find. So I'm going to go in and I'm going to put X equals 30 to get a vertical line. So back to the table or to the graph, click underneath, X equals 30. Puts us a vertical line. Now we're not really seeing the vertical line, so we have to, you can roll your mouse, you can hit the minus to see it. So there's our X equals 30, and when X is equal to 30, we see the Y value is 43.848. So to answer this question, the temperature is 43.484, and it was in degrees Fahrenheit. For C, estimate how many minutes it will take for the soup to reach 90 degrees Fahrenheit. So 90 degrees Fahrenheit is the y value. So this time we're saying, okay, well, y is equal to 90. How many minutes? So that's our x value that we do not know. So we're going to go over here to our graph again, click below to get a new box, and we are saying this time that y equals 90. When you do a y equals, it's going to be a horizontal line, and you're not seeing where it crosses the vertical line, you're seeing where it crosses our regression line. So right here, at this point right here, y is 90, and the x is 14.744. So that is going to be your answer right there, is at 14.744. That's your x value when the y is 90. So that answer, how many minutes? It's going to take 14.744 minutes. And that is how you do exponential regression.